Hello there folks, welcome to Learn Extra and to another wonderful show in our exam revision series. My name is Mark Ancelotti and I'm going to be working through finance with you today. I just want to remind you viewers, finance is in paper 1 and remember that the finance that can be examined is both from grade 11 and grade 12. Without further ado, let's dive in and see what we've prepared over here. I want to remind you of all of the important components of finance that you need to prepare yourself with before you write the examination. So one of the things you must always look at is nominal and effective interest rates, and I'm going to unpack that during today's lesson. Another thing we need to understand is the terminology around depreciation. So in the examination, sometimes the question will either say linear or straight line depreciation or on the reducing balance. And we need to understand that that's a different form of calculation. Again, more about that later on in the show. Probably most important in grade 12 is annuities. So we need to see what is an annuity, what constitutes either the FV or the PV and how we use those to perform our calculations. Big again, introduced in grade 11, but mostly in grade 12 is a sinking fund concept, which usually leads to a future value annuity, and we're going to talk about a sinking fund question. And then, of course, calculating the balance outstanding. All of that together in a nutshell will summarize grade 11 and grade 12 finance. Let's look in a bit of greater detail in terms of our summary. There's a lot of information here. So I would always invite you to read slowly, to read carefully, and to highlight what you think is important. Leanne is saving for university and decides to put her money into a fixed deposit, paying 10% per annum compounded annually for the first 5 years. Realize that this is linked to some kind of compounding. Okay, when we compound annually, that is the effective rate. That's fine. I'm going to do this annually. For the remainder of the investment period, the interest rate changes to 12% per annum compounded quarterly. That's important. So we need to highlight that. It is a nominal rate, it's 12% per annum compounded quarterly, so I know I've got to take that rate, divide it by 4, and then go and work with it. Leanne starts her saving with 4,000 Rand, that's now. After 3 years, she withdraws 2,000. A final deposit of 8,000 is made 8 years after the initial deposit. How much does Leanne have after 10 years? Sure, there is a huge amount of information there. Some of it really valuable, and some of it is just incidental stuff that you don't need to worry about, like Leanne and going to university. So you've got to learn to sift out what's important to get to the answer. My advice, which is probably the advice that anyone has ever got from any teacher, is to summarize the information in the form of a timeline. Now, you may set it out differently to me or to your teacher, but the critical thing in the timeline is you need to show two things. Number one, when money is going in or going out. And of course, it's linked to a specific time frame. So you're showing me when money goes in or money goes out. And number two, you've got to show where the interest rate is changing. So it's got to reflect, and what I do in the top part is I show the money going in and out, and the bottom part underneath my timeline, I show the changes in the interest rate. So remember that all of that is really, really valuable so that you can go do some kind of calculation. So to save a little bit of time, I've created my timeline and I've put it underneath here. So what I'm showing you over here is that Leanne deposited 4,000 initially. That's a T0. Okay, remember this is showing years. After 3 years, she took out 2,000 Rand. So it says she took out the 2,000 Rand. After 8 years, a final deposit of 8,000 Rand goes in. So on the top line over here, I've just taken from the story all the important bits showing money going in, going out. Different teachers will not necessarily show the money going out. They'll also put a negative because you are minusing that 2,000. So when I go and put into a formula, I'm reflecting it with a negative. Underneath, I am now going to put the interest rate. So I read very carefully. I go back right at the beginning. They said to me, fixed deposit 10% per annum annually for the first 5 years. For the remainder of the investment, 12% per annum compounded quarterly. So what I've got for the first 5 years, I have shown the rate over here as 0.10. It is exactly the same. If you wanted to say 10%, okay, that is 0.1. And similarly for the next 5 years, so from year 5 to year 10, they said 12% quarterly. You could write that as 12% all over 4. I've put it as 0.12 divided by 4. That shouldn't make any difference at all. So remember, get the interest rates, get the money going in or out, and then you're going to go and use your calculator and go and work it out. But here is where I want to suggest a real breakthrough in how you solve these. And by the way, if you're in grade 12, you might have forgotten, this was the real emphasis of grade 11, but it can still be examined in grade 12. So in grade 11, many of you tried to work from the 4,000 and get a total at the 2,000, and then get a total at T5 with the interest rate changes, and then get a total at T8, and then from T8 to get a total at T10. I want to say there's a much better and cleverer way. And the cleverer way is to take every single amount of money that's coming in or going out as a separate piece and take it all the way to the finish line. And the finish line is at year 10. So I'm going to show you what I mean. But it does mean that you have a very big equation as opposed to solving little pieces along the way. So I'm going to start off, let's look here, and I'm going to take this 4,000. Okay, so I'm going to work out what the future value of this whole thing is. And I'm going to take the 4,000 and I'm going to grow it all the way to the finish line at year 10. So what I've got to realize is that for the first 5 years, it grows with compound interest. So 1 plus 0, comma 1. I don't need to put that 0 afterwards. And that is to the power of 5. But that hasn't taken me to the end. It's taken me to this part over here. Then I need to grow that all the way to the end. So I add another bracket. Now for viewers at home, I hope you're not confused. What would have happened here is I would have got a total. This total after 5 years would effectively be the present value that would then grow with that second bracket. So when you are taking an amount like this 4,000 all the way to the end, you grow the brackets on for each of the changes in the compounding. So now for another 5 years, my interest rate is going to be 1 plus 0, 12 over 4. Please remember, it's a quarterly rate, so I'm going to do this quarterly. So there are 4 compoundings per annum. Remember, the denominator where you divide it by 4 to get the interest rate per period will raise to the power of 4 because there are 4 quarters in every year, and I must write times 5. Of course, you can just write 20, but I'm just reflecting that over the 5 years, interest would have been calculated 4 times for every one of those 5 years. Now, I've done the 4,000, but I'm not going to stop there. There's still a lot more. So I don't finish. I don't use my calculator. I go to the next piece. I take that to the end, and I take every deposit or withdrawal as part of the formula and take it to the end. So look here what I do with the 2,000. So I'm working from my timeline, and I say now 2,000 is going to go. Because I'm going to battle to fit it all in, I'm going to write it just slightly underneath, but it's all on the same line. Minus 2,000. Now I know that this 2,000 is going to grow and compound for another 2 years to T5. Okay, so I've got to grow it at this particular interest rate underneath. So I'm going to say this would be 1 plus 0, 1, 0. And that is going to be raised for 2 years. But remember, I'm taking it all the way to the finish line. So I've only taken it to year 5. It's still going to keep compounding, and I must take it for the next 5 years, which will be exactly the same as that last bracket in the first part. So this is 1 plus 0, 12, all over 4 to the power of 4 times 5. And then don't forget, we still had another deposit of that 8,000. So this is still all on the same line. Put in your 8,000. That needs to grow just this last little bit over here. So remember, that's only 2 years. And when you say what interest rate, well, your timeline helps you. For this component here, the interest rate is 12% per annum compounded quarterly. So I'm going to say, well, the interest rate will be 1 plus 0, 12 all over 4. There are 4 compoundings per year, but there were only 2 years remaining. Now you have done everything that the examiner needs to see prior to the final answer. So if I can just remind you at home, your marks that you'll be awarded in the matric final exam are for the creation of the formula. There's only one more mark for the final answer, and that's all I need to get to. Can you remember how many decimal places we round off to? Always 2, because we're dealing with finance. Unless the examiner says nearest whole number, nearest rand, or whatever, always 2 decimal places without any further information. I'm now going to type this in to my calculator. Okay, it is a big sum. So let me just see, I'm going to run out of space. I'll move my calculator now. So I'll start off. I've got my 4,000. Then I'm going to say this is 1 plus 0.1. Let me just put the 0 in nicely, 0.1. That will be raised to the power of 5. I hope you're all following and that you're using this fancy Casio calculator. And then here, remember the second bracket. And the calculator knows when brackets touch that we're multiplying those solutions. Press your fraction button, 0.12. Put that over 4, because remember it was quarterly. Close your bracket, all to the power. I could put 20, but I'm just showing exactly what I've got in my formula, 4 times 5. Remember to scroll out, so you're scrolling down. Then I go minus 2,000. And then I just got to move this over so I can see the rest of my page. And then I'm going to put my bracket. This is 1 plus 0.1. Close that bracket, raise it to the power of 2. Let's go out, put our next bracket, 1 plus. And again, this was that nominal quarterly rate, 0.12, all over 4. Scroll out, raise that to the power of also 4 times 5. Remember to scroll to the right so I can work down, and then I've got my last little component, plus 8,000. Remember to work carefully. Your calculator slows down as you type more and more. So look at your screen and make sure that everything you're pressing is reflected there carefully. You don't want to lose marks for silly mistakes. And you might notice now on the screen that it starts flashing black. That's the calculator's way of saying it's getting to the end of its memory capacity, so you don't want to carry on too much further. So let's put in this. It's 0.12. Scroll down to the bottom, put it to the power of 4, divide by 4, close it to the power of 4 times 2, and because I'm running out of space, shucks, I've run out of space. So the calculator is not going to let me do that, so I'm going to show you what we can do. So when all else fails, I've just run out by one place, this is what could happen in the examination. I'm going to say equals. Now that will be the answer to the first part of my sum. And I suppose it's a very good time to show you how to save and retrieve answers, because in the matric exam, if you're going to be successful in finance, you need to be able to save, store it in the calculator, and then to retrieve it later. So look what I'm going to do over here. I'm going to tell the calculator I want to save this answer. I definitely don't want to round off yet because it's not my final answer. And you might see there just above the RCL is an STO button. And that requires a shift because it's a second function. So I'm going to say shift. And you'll see a little S up at the top left of your screen. And then I'm going to say store. Now the calculator is waiting for me to say, where are you storing? And you can store it in any one of those red partitions. So I'm going to store it into A. Now that shows me straight away that the answer has gone into A. I can retrieve that answer from A just now. So I just want to minimize and just show you what I've done. Okay, this first part, that I always do this on my screen so anyone marking knows that I've stored it into A. It also helps me to know where I've stored something so I can retrieve it from my calculator. So I've got that first part of my answer. Okay, so I'm going to call back my calculator, and then I'm going to say I want to give this second part over here, this 8,000, so let's go type it in. The calculator's now got fresh memory, so it's not recalling everything else. 1 plus, put the 0.12, put that all over 4, scroll out, put that to the power of 4 times 2, which I can say to the power of 8. And what I can do now is if I want to add to what I had previously, I can tell the calculator to call up that answer from A. So I can say I've got this 8,000 plus, now A is there and you can see it's red. If I want to access the A, all I do is I click alpha and then I click A. Oops, let's click the A. And what it's doing is it's saying take that previous answer that you had for A and add the two together, and that's how I can recall it. There are different ways of recalling, but that's one of them. Press equals, and that now has given me my final answer. And the beauty of it all is at this stage I can now round off. So it's 17,398 and 41 cents. Remember, you round off to 2 decimal places, so look at the third place to see if you're rounding up or down. Okay, so let's just write there. That will be 17,398,41. Okay, we're going to go for a short break. Stay tuned. We'll be back shortly. Welcome back from the break. We're now going to resume with our next question on finance. So let's have a look over here. We're looking at question 3, and now for the first time we're getting to grade 12 annuities, which I'm sure you've all been waiting for. Let's have a look. Nosizwe's parents are considering taking a bank loan of 40,000 Rand to cover the cost of their first year at university. Nosizwe, if you are watching, that's a lot of money. You better work hard in these exams to get into university. Then they offered an interest rate of 14.75% compounded monthly. That's really, really important. So we can see that the rate is a nominal rate. So we are allowed to take that rate and then divide it by 12. Remember that R is the interest rate per period. So if you're doing a monthly, it would be the interest rate per month. R is the interest rate per period. They're going to pay back the loan in 12 equal monthly installments. So the nice thing is I know what the N is going to be starting 1 month after receiving the loan. Now, when you have a present value annuity and whenever you're paying back a loan, it's so important that you read that final sentence very carefully. The normal present value annuity will always have its first payment at the end of the first period. So for example, if you're working monthly, the period is months, your first payment is at the end of the first month. If you're working quarterly, then what will happen is your first payment will be at the end of the first quarter. And quarters are 3 months, because you know that the 4 3s make 12. So at the end of the third year, your first payment will be made. That just means it's a normal annuity. So don't panic and do anything different. It means you can substitute directly into the formula. Now the challenge for all of you at home is to say, is this a present value or is this a future value annuity? And for me, there are 2 real clues. One of them, the first clue, is that we're dealing with a loan. And so when you're paying back a loan and you're making regular monthly installments, that's an annuity, and that would be a PV annuity. But also we know that we're trying to take this 40,000 and pay it off and take it down to 0. That reinforces my thinking to say that is a present value annuity. So let's have a look. We write down the present value formula. Remember, the present value annuity formula is equal to X. Open up your big brackets. This is on the matric formula sheet, so don't panic there. 1 minus 1 plus the interest rate per period to the power of negative n. And that is all over to the power, all over the R. Now you need to go and solve for all the different unknowns. So say to yourself, what do I have? What do I need? I need to calculate the monthly payment. So that says to me, I need to find X, which means then I must have everything else. So the present value, yes, I know that. That's what Nosizwe's parents are going to borrow is 40,000. Then I also know the interest rate because they told me that it was 14.75% per annum compounded monthly. So important to see the compounding linking to the rate. So that would be, for me, 0.1475 all over 12. Remember, other students, you can write that as 14.75% and write that over 12. What else am I missing is the N. So let's read carefully. We are paying over 1 year starting at the end of the first month, so there will be full 12 payments done monthly. N is 12. And then all I've got to do is substitute those values into the correct formula. Make sure you use the correct annuity formula. So let's go. 40,000, 1, 2, 3 is equal to this X. And then over here, go and put in the unknowns. So this is going to be 1 minus 1 plus. And the interest rate, 14.75, so it's 0.1475 all over 12. And that will be to the power of negative 12. And that is all over 0.1475 over 12. And then I'm going to type that into a calculator. Now look what I'm going to do to try and help me get to the answer. So I'm not going to do too many steps at once, but I'm going to work out what is inside that bracket. So let's call up my trusty Casio calculator, and let's go work this out. So I'm working inside the big bracket. So start off, go to your fraction button, because I'm working in the numerator of this fraction, 1 minus. The way you see it is exactly the way you're going to type it. Bracket 1 plus. Now there's a fraction, so I'm going to hit the fraction button again, 0.1475. Scroll out so you can go down underneath, divided by 12 because it was a monthly rate. Close your bracket, all to the power of, and that's negative 12. Then make sure that you scroll all the way down to the bottom so you can put in the rate. Scroll down, there I'm now at the bottom. Press your fraction button because again that rate is going to be converted to a monthly rate, 0.1475. And remember that's monthly all over 12 equals. Excuse me. Now, this is 11.0938. Do not round off. You may not ever round off until you are giving the final answer. So I'm putting dot, dot, dot. And the viewers at home are saying, but Mark, you're not allowed to round off. And I'm saying by putting dot, 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 I'm not rounding off. I'm keeping every decimal place, but I'm not reflecting it by writing everything. Now, what I'm going to do is I'm going to click on all clear. Or I can store it. Let's just go and store this. So I'm going to shift, store it. Now, I've used A and B earlier. I can go to C, but I want to show you, if I click on A, it doesn't matter. It will overwrite a previous answer. So now this is stored in A. All right? So I can tell the examiner, I can remind myself, I've stored it in A. And so this is not too complicated to get X on its own. I just know it's going to be 40,000 divided by that answer from A. So you don't have to keep all the decimal places. You don't have to write 101 things. It's a much quicker way of getting to an answer. Then I just pull it up on the calculator. I'm going to say, let's go 40,000 divided by, and I'm just going to say alpha A. And that'll give me the answer. And so I work out that my installment is going to be 3,605 Rand and 62 cents. So let's write that down. It's at this point that I am allowed to round off because this is a final answer. And so there, 61 cents, but because that 5 is there, it'll round up to 62 cents. Okay, so what I've done at this stage is I've shown you the basics of a present value annuity. Remember, you'll have to solve for an unknown. The only unknown that you won't need to solve for at school level is the R. At school, we don't know how to solve for that R in an annuity, only for the annuity. Let's look at part B. Part B, very, very important, finding the balance outstanding. The balance outstanding is probably the most important concept in terms of playing with changing annuities. And so when we work out the balance outstanding, there are two different ways in which it's taught at school. One of them always works, one of them doesn't always work. So I'm going to rather teach you now on air the method that will always work. And I want to paint a scenario for you. So just assume that you've got a loan in one bank account and you're making all of your payments to pay off that loan in a separate bank account. So what happens is the bank account where you're owing money, that's going to keep growing and keep growing and keep growing. The account where you're making all your payments that would have paid off the loan, that will be growing as an annuity. If you find out the difference between those two bank accounts at any point in time, that's the balance outstanding owing on your loan. So I'll just remind you, what we're always doing is we take the loan, grow it with interest, minus all of your payments with interest. The difference at any point in time is the balance outstanding. Let me try and show you here. So the balance outstanding at any particular point in time is what I do is I always take the loan and I grow it with interest. Okay, so the loan is growing as if you've never made any payments, minus the future value, because you're going to be making all these payments all the time. So they're going into an account and into an account and into an account. And if it was a separate account, that grows, and that actually is a future value annuity because it's growing up to some total. So you minus the future value annuity amount for all of those payments. So let's go and do this. So I'm going to determine the balance outstanding on the loan immediately after the 8th payment has been made. So take your loan. Your loan was 40,000 plus the interest rate, I think it was 14.75. Yep. So it's 14.75, 0.1475 over 12. And I'm wanting to find out the balance outstanding after the 8th payment. So I go put to the power of 8 minus now the future value of all of those payments. So I'm just going to show you over here in case you can't remember that formula, which is on the matric formula sheet. Future value for savings, growing an amount of money. Still the installment. Still looks very, very similar to the other PV formula. So it's 1 plus r to the power of n minus 1, and that is all over r. So that's the formula that I'm going to use to work out the total of all of my payments. Remember, you're assuming that you're treating them as separate bank accounts. So take your loan as if you've never paid it for 8 months. Take all your payments as if they've never paid off the loan for 8 months. The difference between those two bank accounts will give you the balance outstanding. And so whilst it's quite a busy formula and there's a lot being written here, it's not complicated conceptually. So now I needed to know the balance outstanding will be based on the installment we created earlier. So the installment amount was 3,605 and 62 cents. And then let's go and say 1 plus the interest rate. Let me just clear up a bit of space above here. Okay, so the interest rate was 0.1475 all over 12, and that is to the power of 8 minus 1, and that is all over the interest, 0.1475 over 12. And like me, I'm sure when you do these, you say, wow, it's kind of taking up a whole screen to try and finish a question. But that's what happens. So now, let's go pull up our calculator so we can go and perform that calculation. So I type the first part, 40,000. And remember, this is just compounding up to the point where you wanted the balance outstanding. So you take the loan, grow it with interest. Okay, put that over 12 because it was monthly, and raise that to the power of 8. And then remember, you were minusing the future value of all those payments. So now I get to the annuity part, and it will be for the same period of time that you've been making all those payments up to the same point. 3605.62. And then, of course, now I've got the big bracket of the annuity, so make sure you call the fraction, open your bracket, 1 plus, again fraction because you're putting your rate over 12, 0.1475, put that over 12, scroll out, close your bracket. Remember that you've got to say, well, how many payments for this annuity? And that was to the power of 8. Minus 1. And then, of course, we must go to the bottom of our bracket so that we can do the interest component. Remember, you're dividing by r with the annuity formula. The annuity formula looks ugly, but there's so many marks that you can be awarded in the matric exam if you choose the correct formula and you just work carefully. So go underneath to the 12, scroll out. Remember, I must just close off my bracket and press equals. And that there would be the balance outstanding at this particular point after 8 months. So I'm going to go put that in. So that would be 13,989. And now I've got to be careful when I round off. It says 899, so that would round up, comma, 90. All right. Okay, we're going to go for a short break. Stay tuned. We'll be back shortly. Okay, let's move on to our next question. We're going to look at question 4. Question 4 is all about a sinking fund. So you're not going to get all of these questions in the matric exam. Finance really makes up roughly 20 marks in your matric finals. So we have to ask maybe 1 or 2 of these concepts and not all of them together. But a sinking fund is where we can put the future value annuity, and we can do a whole lot of depreciation and compound increase. So let's read this question here. It says a new compressor is purchased for a panel beating shop for an amount of 185,000 Rand. If you don't know what a compressor is, it doesn't really matter. What you know is that you're purchasing something and you know the total amount. So don't get caught up on the little itty-bitties of the question. It says the machine depreciates at a rate of 20%. Hey, that's important. So we got depreciation at a rate of 20% on a straight line balance. Now, the straight line basis or the reducing basis or reducing balance tell us 2 very different things, and you've got to read carefully and know how the depreciation will take place. Straight line or linear depreciation is simple interest. Let me repeat that. Straight line or linear depreciation, so when they say on the straight line or linear depreciation, that's simple interest. When they say depreciation on the compound or sometimes reducing balance, you've got to know that's compound. So they might not even mention compound. They will say reducing balance, you know that's compound. So that's very important for me. Now they say determine the scrap value of the machinery. The scrap value is just the value after 3 years. Now this was an annual rate, it's an effective rate, so I can just go and work that out. So I'm going to work out what is the future value of this machinery. So I take what it is worth now, 1 minus R times N. This is simple depreciation. I know because it's on a straight line balance. So I know that this machinery, whilst it's worth 185,000 now, 1 minus the interest rate, where am I, is 20%, 0,2, multiplied by the number of years. This is what the machinery is going to be worth after 3 years. So again, let's go and pull it up on the calculator. 185,000 1 minus, remember you've got to see that minus when it's depreciation, whether it's compound or simple, you've got to see that minus. And that was the rate multiplied by the number of years. Close your bracket. That there is my value. So it will depreciate to a value of 74,000 Rand. Perfect. Let's go and see what the next question is going to ask us. So it says the cost of a new machine will increase by 7.2% per annum. Now, when they don't tell you a type of compounding, you need to know that increasing by a certain rate is generally inflation, and inflation is compound interest. So unless they tell you otherwise, when something is increasing by a certain rate every year, that will be compound interest. So what I'm working out now is the future value of what the machinery will cost me in 3 years' time. This is all building up to a traditional sinking fund question. So future value is going to be whatever I start off now, I'm growing it 1 plus R to the power of N. That's a compound interest formula. The nice thing is these calculations are taking place annually. There is no compounding linked to this rate. It's an annual rate, so I can do this annually. I'm just reminding myself, okay, the machinery started off at 185,000. The interest rate is 7.2%. R represents 7.2 as 0.72, but you can put 7.2 over 100. That's what I've got already. That's 7% in the hundredths, and that is to the power of 3. So let's go and pull up our calculator so we can go and work out what this bit is. So it's going to be 185,000. Whoops. Open the bracket. And then it's 1 plus. Now, of course, you don't have to type in 1 plus. You could have just put it as 1,072, but I'm just typing it exactly as I see it on my page. And remember that we were compounding for 3 years because I was taking it to the same point in time. And now this tells me what I would have to buy this new machinery. So it increased at this rate. So this new machine in 3 years' time, based on this projected rate, would be 227,906 Rand and 17 cents. And I'm allowed to round off. It's my final answer at this stage. Now let's see. Do we have a part C? I think I'm on the next page. Yes, I've still got the same question. Now it says calculate the value required in the sinking fund. The sinking fund is the fund that you need to purchase something. So it's how much money would you have needed if you traded in the old machine and you knew what the new machine would cost. What's the difference between those two? So the sinking fund value is always equal to the new projected price, so that's the new price, minus the trade or the scrap, depending on how the question defines that. So I've just got to remember what the new value was. The new value, let's just go back a page quickly. Okay, the new value, I've got it, 227,906. Okay, so 227,906 Rand and 17 cents minuses what the trade value was, and the trade value was 74,000 Rand. That we don't need a calculator for, that's not too bad. That will be 153,906 Rand and 17 cents. Okay, so this is how much you need extra. So if you took this as a trade and you knew that's what you needed, this is what a sinking fund is all about. The goal is to work out the sinking fund value and then to say to ourselves, I needed to put money away so that I eventually get to that total. And the challenge is, well, what would you put away to get to there? All right, so let's go and see part D. There's almost always going to be a part D. And it says a sinking fund is set up to realize the amount required to purchase the compressor. And to help me, I'm just going to write it here because it's going to go off my screen. So I needed to realize this amount. This is the amount that I needed in my sinking fund. If the bank quote interest rate, or the quoted bank interest rate is 9% per annum compounded monthly. If the rate is given monthly, I must see if the payments are going to be monthly. If they correlate, it's great. If not, I have to change the rate. So I've got a monthly rate, it's a nominal rate. Payments start immediately and then are made at the end of each month. That's interesting, and I want to come back to that. Determine the value of the monthly payments over the 3-year period. So I'm trying to work out what I've got to put away every month to get to a value in the future. So first of all, if I'm paying the same amount every single month, you've got to say to me at home, that's an annuity. That's a perfect example of an annuity when you're making the same regular payment. The other thing you've got to say to me at home is, we've got a future value. So it's going to be a future value annuity. You're not bringing it down to zero, you're taking it up to a value. So I'm going to write down the formula. I always write the formula. It really helps me to visualize where I'm going to. Remember, to the power of n minus 1 all over r. And then I've got to work out all of my different unknowns. So x, I don't know. That's the real question. The future value, yes, I know what the future value is. That's what we created. That is the value of the sinking fund. That's what I have to have saved right at the end of all of this. The interest rate, well, they gave me a nominal rate. So they said it was 0.09. Remember, R is the interest rate per period. Per period, per month. So I needed to put it over 12. This is now giving me a monthly rate. And then there is N. And I wanted to pause on the N, and I didn't gloss over the wording. There's something very, very clever here, creative, that you've got to read. Look carefully. It says, payments start immediately and are then made at the end of each month. So you've got to say to yourself, over a year, if you pay at the end of each month, there'll be 12 payments. Over 3 years, if you pay at the end of each month, there are 36 payments. But if you start immediately and then at the end of each month, there is an additional payment. And you've got to realize that there are n plus 1 payments. So over the 3 years, and this is the the challenge that this question was presenting here. And you've got to look out for that. Over 3 years, because there are 12 in each year, because it's monthly, there would be 36, and I've got that immediately. Remember, immediately means usually an additional payment if you then pay at the end of each month. And so n is going to be 37. Now substitute everything into my formula, and then I'm going to go and solve, and I'm going to use my calculator. So let's just substitute in 153,906.17 is equal to the x. Then over here, 1 plus the interest rate was 9% compounded monthly, and that is to the power of 37. Don't forget that 37 minus 1 all over 0.09 over 12. And I'm going to get this answer, okay, and I'm going to store it and then divide it across to isolate the x. So that's where I'll pull up my calculator. Okay, we're working in the bracket. So inside the bracket, let's go fraction to the top, open your bracket. Type it exactly as you see the top. 1 plus, again, fraction button 0.09. Put that over 12. And that there is to the power of 37 because there was an additional payment, minus 1. And put that all over that rate. Again, press your fraction button, 0.09. Put that over 12 because it was a monthly rate. Press equals. And now that gives me the value of the bracket. I'm going to store that. Okay, remember shift, store. Make sure it says the store. Now choose somewhere. I can go anywhere. Just for fun, I'm going to D. Okay, so I'm going to press the D. It always shows you on your calculator the answer has gone into D. So I'm just going to minimize that. Okay. Now I'm going to put my answer, store it into D. So then if I want X on its own, X is going to be 153,906.17 divided by D, and that will give me the installment. Okay, so let's pull up my calculator. It has got the D stored in, so it's 153,906.17. I say divide, and then I click on alpha, so it lets me call up one of the variables, call up D, and that will give me my final answer. So this is going to be 3,624 Rand and 62 cents. Again, look on the calculator screen, make sure that you round off to 2 decimal places, and that's what goes up to 62. All right, and so that is where I work out the installment. This is a perfect example of a sinking fund. There's depreciation, there's an interest rate increase, usually an inflationary increase. The difference between the two is what you need as a sinking fund. That's the amount that you need to pay the difference, and then we work out what the monthly installments are to get to that sinking fund amount. Remember, sinking fund, future value annuity. That takes us to the end of that question. Okay, let's look at question 5. Question 5 means that we're right at the end of today's show. It's going to be a nasty question. It's going to challenge you. It's in the form of problem solving. So don't be put off. See if you can learn something from this. One of the things that we haven't done yet in this finance segment is solve for n. And remember, when you're solving for n, it's quite nasty. That's why we introduce logs in matric. You're going to have to use your logs to solve for the n. So let's have a look here. It says, how much can you live off as a monthly allowance if 100,000 Rand is invested into an account which gains interest at a rate of 8% per annum compounded monthly, and the money must provide income for 2 years only? Sure, when I look at that, I'm saying to myself, that doesn't look like a future value, neither does it look like a present value annuity. And this is where you've got to think very carefully. This is how the examiner disguises a question so you're not entirely sure. So if you've listened to the clues earlier on in today's lesson, you will know what to do. So let's remind ourselves. A present value says to us that you are taking something down to 0, And each one of the x's, the installments, work against. They eat away against that PV. A future value takes something from 0 and all of your installments work to build up the total. Now let's look carefully, because you're not paying in, but you're taking money out. You want this 100,000 Rand to last you for 2 years only. That means that 100,000 Rand is going to come down to 0. And if you're taking money out as a monthly withdrawal, it is very similar to if you were paying money to reduce a loan. And so the annuity formula can be used for both instances. And this is where we can use the annuity formula even though you're making a withdrawal, and I'm going to use the present value annuity. So let's just create some space. I know that I'm going to use a present value annuity. Try to think about why I've managed to say that. So let's go. The present value annuity is going to be your x, 1 minus 1 plus r to the power of negative n all over r. And then I must go and work out, well, the present value will be 100,000. I know that the interest rate is 8%, but it's a monthly nominal rate, so I can put it over there. And I know it must provide income for 2 years only. And so n is going to be, because it's done monthly, 2 times the 12, which then would be 24 months. And then I must just work out what the x would be to take it down. And that's very, very similar to what I've been doing all along over here. So present value, let's type it all up. So I've got my 100,000. I've got my x that I'm going to go and solve for. The interest rate, which was 0,08 all over 12 to the power of negative 24. And that is all over 0,08 over 12. Now, I'm going to save a bit of time. So what I'm going to do is I'm going to say to get x on its own, I have to divide that to the other side. So look what I'm going to do. Now that I'm more familiar with what I'm doing, I'm quite comfortable, I'm going to say let's put in 100,000. And I'm going to say let's go and divide. And then I'm going to put that whole big bracket over here. So I'm going to say, okay, I'm dividing by this annuity part. 1 minus, it's going to be another bracket. It's exactly as you see it, that's how you type it. Oops, I must just scroll out of there and just scroll to the front. 1 plus 0.08 all over 12. And remember that that was being raised. I always know it's a negative exponent when I'm dealing with a PV, power of negative 24. Scroll down, put your fraction, 0.08 all over your 12. Scroll to the end so you make sure you close off your brackets, otherwise your calculator will tell you there's an error. Press equals, and this now has told me what I can take out. So it's 4,522 and 73 cents. All right, there is a second part to this question, and the second part says to us, if you need a monthly income of 3,500 Rand instead, so instead of me taking that 4,500, I need a monthly income of 3,500. So now the X has been given to you. Determine how many full withdrawals of 3,500 there can be made. Stop and think about it. They're saying how many withdrawals. That's talking to the duration of the investment. That's actually saying to me, we're really solving for N. And you've got to know that as soon as you're solving for N, you are using logs. So look out for that. It's cumbersome and messy, but it's not difficult if you put into the right formula and you know exactly what you're looking for. You know it's logs, so you're going to go and use some logs. So I've got to use the information from earlier, so it was easy enough. I know that the interest rate was 8%. It was done monthly. I'm going to solve for N. So let's put this whole thing together. I had 100,000. I know that I want to take 3,500 out of that. Remember that this is a PV annuity formula, so it's the 1 minus 1 plus. Remember that the interest rate is 8%, 0.08. It's done monthly to the power of negative n, all over 0.08 over 12. Now you have to solve for n. And this is where you've got to think very, very carefully and just unpack the equation by taking things over to the other side. But always remember that when you take something to the other side, you reverse its operation. So what I'll do here is I'll divide by the 3,500. Which is open up now the bracket, and at the same time this denominator I'm going to multiply across to the other side. So what does that leave me on the right hand side? 1 minus 1 plus 0.08 over 12 to the power of negative n. We get in there. We're very close to getting there. So I'm going to now quickly work out what that is. So this is where I'm going to use a calculator all the way along. So I'm going to say, let's put 100,000. Put that all over 3,500. Scroll out, so I can say times, put your bracket 0.08. Put that over 12. Okay, 4 over 21. And you know what I'm going to do is I'm actually going to take this 1 over now, straight after it. So I'm going to say let's minus 1, because I'm trying to save a little bit of time. Oops, something went wrong there. Answer minus 1. And that's going to give me negative 17 over 21. Let's see what I've got on the other side. The other side, because that 1 is gone, would have had negative. And then I've got a bracket to the power of negative n. Now I'm going to multiply both sides by a negative so I can make that positive and I can make that positive. Now you might be saying, why aren't you working the bracket? I just don't like the way that it looks. It's so much that I keep carrying. So I'm saying maybe the calculator will give me a nicer answer to have in that bracket. So let's go and say 1 plus 0.08. Put that all over 12. And let's see what it gives me. That's nicer. 151 over 50. Now it's at this stage that you're going to use logs. And it really is dependent on how you've been taught at school as to how you form the logs and use the logs. But perhaps one of the more conventional ways is to say, when you've got something raised to a power, this over here will become the base of the log. So it goes to the other side, and what we do is we say, well, it's the log where this is a base, 151 over 150, of the number 17 over 21. Remember, the base there will become the base in logs, and that leaves me with negative n. This log has to give you a negative answer. Always, when you're solving for n in a PV, if that does not give you a negative answer, something's gone wrong. And then you must go back and check your signs. Because if you get a negative and you're solving for negative n, that then will enable me to get to a positive n value. And so now let's pull up our calculator. Remember that on the right hand side, just under the on button, is the log button that you want, and that log there enables you to choose the base that you want. So press my fraction button, 151 all over 150. Scroll so I can get to the number part. That was just the base part, and again I need a fraction, and that'll be 17 all over 21. Press equals. Don't panic. We wanted it to be negative because it was negative n is equal to this. So then I can go and solve, and I can say n is 31, 80, blah, blah, blah. Now let's go and interpret what that means. What that is telling me is that if I chose to withdraw 3,500 at the end of every month, it will last for 31 and a bit months. It's not going to last for the full 32 months. So we've got to answer the question very carefully. If the question says to me, how long does it last? Well, 31.8 months. If they say, how many full withdrawals? 31 withdrawals. If they say how many withdrawals, well, I know there are 32, but the final one is slightly less. So there are 31 full plus one slightly smaller, which is the final withdrawal. So I'm going to go back to the question and ensure that I've answered it carefully. And the question says, how many full withdrawals? So then it's easy for me to say, therefore, 31 full withdrawals. All right. That is a challenging question. That really is a challenging question, especially when you incorporate logs to solve for n. But you know it's going to come up. You know that when you're solving for n, you're going to use logs. So even if you're not entirely sure, you can get lots of part marks by showing the examiner you're using logs to unpack for n. Well, folks, that takes us to the end of today's segment on finance. I really hope that you've learned a lot. We've covered every single concept of finance that could come up in the matric exam from grade 11 all the way through to grade 12. All I can do now is wish you good luck for your examinations. Keep watching the shows. There's lots and lots of revision sessions covering your whole matric syllabus. Take care. It's goodbye from me, Mark and Salati. Cheerio.